Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Namo Buddhaya, and Salam Harmoni. Let me introduce myself first. My name is Anak Agung Bagus Lantik Kusuma.
My name is Iputura Medima Putra.
My complete name is Idalia Francisca Viegas.
My student number is 22 15 10 and 48.
My student number is 22151010522.
And my student number 22 15 10 and 84.
In this time, I want to explain to you about limit involving a trigonometric function. Now, for the previous chapter, we have explained about Theorema D in a chapter Theorema Limit, which states that the limit of the function can be determined through the substitution technique. So, to determine the limit of the trigonometry function, we apply Theorema B of the previous subcap chapter. Regarding the function that are applied to determine the limit, now from the theorem we can determine trigonometric function. Trigonometry limit is a limit that is usually working on the trigonometric function. The closest value to the limit of the function, namely in the form of a special angle, namely an angle that has a simple value, as well as in the process the substitution rules also apply to this trigonometric limit function. Okay, in limit trigonometric there are two theorema, which is theorema A and theorema B. In the theorem A, we have 6 steps to find the limit using a substitution technique. Like the first one is limit sin t equals sin c. Using a substitution technique, and same like number 2 until number 6 until cosecant. So for the example, I will give you an example. The first one is limit x close to 0 t power by 2 cos t divided by t plus 1. We can also divide it into two types like this, and then we substitution the limit. Therefore 0 power by 2 divided by t plus 1, and the second type is limit t close to 0 cos t, and then we substitution. We have this because whatever divided by 0, the value is 0, and then cos 0 is equals 1, so we have 0 times 1 equals 0. Okay, now we go into the second theorem, namely theorem B, which is called the special trigonometry limit. Therefore, this theorem make us easier for us to determine the limit. For the first one is limit t to 0 sin t divided by t equals 1, and then the second one is limit t to 0 1 mean cos t divided by t equals 0. This is the rules. As we see, so we go to the example. Example 2, limit x to 0 sin 3x divided by x. We First, we must know if times by 1 divide 1 because the value is same. So that we have sin x times 3 divided by x times 1. Sin x divided x equals 1. So we have 1 times 3 equals 3. So that for my explanation. For the another example will be continued by my friend Idalia and Romi. Thank you.
Now I'm going to continue the example to number 3. And here's the example. Find the limit. Limit t to 0 cos quadrat t per 1 plus sin t. We can just substitute by t to 0. Equal cos quadrat t change to 0 per 1 plus sin t change to 0 equal cos quadrat equal 0, 1 plus sin t equal 0 equal 1. And here's the result. Now move to another example. Lim t to 0 t quadrat cos t per t plus 1. Now we have to use the multiplication rule in theorem A equal lim t to 0 t quadrat plus t plus 1 multiplied by lim t to 0 cos t equal now we have to make substitute t quadrat to 0 quadrat plus t plus 1 equal 0 plus 1 multiplied by cos t equal 1 equal 0 quadrat equal 0 per 0 plus 1 equal 1 multiplied by 1 equal 0 plus 1 equals 0 multiplied by 1 equal 0 multiplied by 1 equals 0. And here's the final result. I think that's all from me. Now my friend Romy will continue. Thank you very much.
So in here we will discussion and explain about the theorem of limit trigonometry. So actually I will explain about the example and application about limit of trigonometry. So let's get started. Okay, so this is the question number 1. For your information, I take this question in the module of basic mathematics, especially in number 5 at 1.4. So to solve this question, we must use the theorem of limit trigonometry, especially in theorem B in the module of basic mathematics. So in the theorem B, it said about lim t to 0 sin t per t is equal to 1. So use this equation, we can solve this question. You can write this lim x to 0 sin x per 2x. So use the equation of limit, especially in the past of the module. We can write this 2 in the left side of lim x to 0. So it will be 1 per 2 lim x to 0 sin x per x, 1 per 2 times lim x to 0 sin x per x. Okay, after that we know about lim x to 0 sin x per x is equal to 1. So the result is 1 per 2. Okay, this is the next example. So the next example, I take it in the Google. So in here we have lim x to 0 sin 3x per 6x. To solve this question, we still use the same equation. So the same question is lim t to 0 sin t per t is equal to 1, and then we can solve this equation. We can write this lim x to 0 sin 3x per 6x is equal to lim x to 0 sin 3x per 6x times 1. Why we use 1? So the 1 in the right side, it's not change this equation, so we still use 1 gitu. Okay, and then we can write this lim x to 0 sin 3x per 6x times 3 per 3, and then after that we use the equation to change this determinator, and it will be lim x to 0 sin 3x per 3x times 3 per 6. Okay, after that we know about lim x to 0 sin 3x per 3x is equal to 1 and 3 per 6. So, and then the result is 1 per 2. Okay, that's all for my presentation. So thanks for watching. Om Santi 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 Om. Assalamualaikum warahmatullahi wabarakatuh. Salam budaya, salam sejahtera, shalom, dan salam harmoni.